Okay, hi. I'm going to help you work out this system of equations using the addition method, but we're going to see a problem where it's a dependent system, meaning that there's infinitely many solutions. So, and just so that you review, whenever we have a system of equations, there's three different solutions that you might see. There's one solution where there's the two lines, they intersect, and that means that you have one point that is your answer. You could have the lines do not intersect, and that would, when we work out the algebra, you would have a not true statement like 0 equals 1 or something like that. And then if you have infinitely many solutions, that's called a dependent system. That's what we're going to see this in this situation. The two lines lie right on top of each other. So first, let's use the addition method. So you can multiply any of the equations by any number you want, and then add the equations together. And then you try to do that to eliminate one of the variables. So like I would notice that if I multiply, okay, this coefficient, I'm just looking at these two coefficients right here. And well, I'm sorry, the coefficients are the numbers in the front. So I should have actually 16 and 4. What can I multiply 4 by? So it is like 16. 4, right? If I multiply this 4 by 4, then I'll get 16. If I multiply by -4, that'll be the opposite. So it'll be -16. So, and then when I add them together, those x's are going to cancel. So I'm going to multiply the second equation by -4 so that the x's, when I add the equations together, they're going to cancel. So 16, I'm going to write the first one exactly as seen. And then I'm multiplying the second one. I'm going to multiply it by a -4. We have to remember to do it on both sides of the equation. So I get -16x, -24y, and -28. Then I add the resulting equations together, and now I just wanted the x's to cancel, but actually everything cancels, right? So 0, 0, and 0. So we just get 0 plus 0 is equal to 0, which is true statement, which means that there's infinitely many solutions here. And so since that's the case where they're actually giving you two different equations. They look like different equations. They're actually the same line, just written a little bit differently algebraically. So that's where we have the two lines are lying right on top of each other. So there's actually infinitely many solutions. And here's how we're going to write the solutions. See, all solutions to system equations are an ordered pair, an x value and a y value. Well, since there's infinitely many solutions, the x value, they usually like to say the x value, just let it be x. And then they like, because it's the second one, I suppose, they say let the y value, then we solve for what y would have to be in that situation. So we choose either any two of the original equations and just solve it for y. So I'm going to choose the second one because like it is smaller numbers. So we have 4x plus 6y equals 7. And then so I subtract 4x from both sides, and then I get 6y is equal to -4x plus 7 divided by 6, and I get y is equal to -4x, or 4 6s times x plus 7 6s. 4 6s I can reduce to divide by 2 on both top and bottom. It will give me 2/3, right? Because 4 divided by 2 is 2, 6 divided by 2 is 3. And then what we do, we plug all of this in that I just solved for y here. I know given any x, the y value has to equal -2/3 times that x plus 7/2. So I need more space here, but so I let the x value be anything it wants, and then I took this more simple. You could choose any of the two original equations, but solve one of them for y, and then whatever you get, plug it in right here. And that's the way they want your solutions to look like. So they like this because all you have to do is pick a x, let's say x is 1, then you plug in 1 into this little equation for y, and you can easily start stamping out, giving out the numbers that are solutions to this equation. And like I said, there's infinitely many of them because no matter what you make x, you get another solution. So that's how you do it. And we could double check our answer. So the first one is x, and the second one is a -2/3 x plus 7/2. So exactly what we got. All right. Bye.